All right, welcome. Let's do another free fall problem here, this time with factoring. So we'll do one with factoring, and then in a minute we'll come back and do a different video of how you solve a free fall problem using the quadratic formula. So let's look at this one up here on the top first. This is from a practice exam, page 2, and an egg is thrown upwards off a 72-foot high grandstand at 56 feet a second. So the equation is going to be negative 16t squared plus 56t plus 72. And we're going to start by factoring out common factor and negative common factor. I want to get that negative away from the t squared. And it looks like 8 is the biggest number I can take out. So I'm going to make it into negative 8 on the outside, and it'll be 2t squared minus 7t minus 9. Right? So we rewrite the equation with a negative outside. Now we have this. And this you can either factor with the x method. I think, well, I'll do the x method. I think you can do guess and check, but I'll do the x method just to make sure it's okay with everybody. So 2 times negative 9 is negative 18. Has to add to negative 7. So that's going to be negative 9 and positive 2. And that is going to mean I'm going to factor. Remember, you write down the first coefficient twice, so it's going to be 2t minus 9 and 2t plus 2. And then you divide it by the biggest number that goes into both of these evenly. So the only number that goes in here is 1, so it's going to be 2t plus, minus, it's a minus 9. And this divides by 2, so it's going to be t plus 1. And there's still a negative 8 in front. Don't forget that. So the factors, and I'm going to look to see that you actually, write down the factors correctly. You'll be negative 8 and then parentheses 2t minus 9 and parentheses t plus 1. So we're going to make both of these factors equal to 0 because that's when it hits the ground. The whole height equation is going to equal 0. So if I make that factor equal to 0, t has to equal 9 halves, which is 4.5 seconds. So at 4.5 seconds, it's going to hit the ground. That's going to be over here. 1, 2, 3, 4.5 seconds is going to be right there. This one over here, this parentheses, if that's equal to 0, then t must equal negative 1. So this is if the universe went backwards, and instead of the ball going up, it went down, it would hit on the ground back here, negative 1 second before it was thrown. Okay? So we know those two things right now. We know the x-intercepts, where the parabola intersects the x-axis at negative 1 and 4.5 seconds. To find the axis symmetry, we add those two numbers together. So 4.5 plus negative 1 is 3.5, and I divide that by 2. So I find the average of those two numbers, and that gives me the axis symmetry is 1.75 seconds. So halfway between these two intercepts here is the axis of symmetry at 1.75 seconds. So I'm going to draw a dashed vertical line there at 1.75 seconds. I know that that's where the peak is going to occur. That's where the ball or the egg is going to reach its peak and then come back down. And you want to check that this is equidistant. So this looks like about 2 seconds, 1, 2, and 3/4. And this looks like about 1, 2, and 3/4 seconds also. So it's check that your axis symmetry is equidistant from these two intercepts here. Okay. Once we get to 1.75, we can put that into our calculator and find the height equation. Or I'm sorry, find the height. So 1.75, I'm going to put into storage in A. And also I'm going to put 1 second in there because I'm going to find the height at 1 second in a minute. So I'm going to put 1.75 in A, and I'm going to put 1 second in B, and it'll just make it easy for me to calculate those two times. So the way you do this is I do it on my calculator, negative 16, and then I just go recall A squared plus 56 recall A plus 72. So the height at the axis of symmetry is going to be 121 feet. And now I know I'm going to find the height at 1 second also. So now I'm just going to switch this A to a B on my calculator. So I just scroll through here and say, okay, instead of recall A, I'm going to make it recall B. Just makes it real quick and easy to find. The height at 1 second is going to be 112 feet. And of course, that's going to be the height, the symmetric point also. I don't know where that is yet, but I know that's going to be the height there. The intercept, the y-intercept is going to be at 72 feet, so I know those two times also. I can put them in there. I haven't found the symmetric point yet, but I'll do that in a second. Okay, so now, and this is tricky, to find the difference, to find the symmetric point here at 1 second, I find the difference between the axis of symmetry and that time at 1 second. I can do that in my head as 0.75 seconds. 1.75 minus 1 is 0.75. I'm going to add that to the axis of symmetry. So I'm going to go plus 1.75, and I get 2.5. So the symmetric point here is the difference between these two numbers, these two times, 0.75 seconds, and then add that to the axis of symmetry, which is 1.75, and that is my symmetric point here, which is 2.5 seconds. I'm going to check that. I'm going to graph it and look at it just to make sure it makes sense, but I'm pretty sure that that's right. So let's count off here: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 feet, 10, 20, 30, 40, 150. So the axis symmetry is at 1.75 and 121 feet. That's like right there. It's a little bit above 120 feet. 1 second, it's 112 feet, so that's right around here. And then there's a symmetric point here at 2.5 seconds. 1, 2, right around there at 112 feet also. And that looks like 0.75 seconds both ways there, right? Also, we know at 0 times 0, it's at 72 feet. So that's like right in here. And then it goes all the way down, a nice smooth parabola to -1 second over here. The other side here is just 1.75 times 2. The axis of symmetry times 2 is going to give us a symmetric point for the y-intercept. And that'll be 3.5 seconds. So 1.75 times 2 is 3.5 seconds. So if I go over here and I go over to 1, 2, 3.5, I'm going to be at 72 feet also. So now I just bring this right down through that point to the other x-intercept. And that's my graph like that. So I filled in all the numbers here. I filled this in, and it looks like a nice smooth parabola. So I think that I did it correctly.